Alrighty, in this video here we're going to check out some algebraic expressions, and it's going to be a great time. I'm really looking forward to it. Now these word problems here, these always seem to get people. So we want to write an algebraic expression that models 3 fewer than 4 times a number, x. So our number is x, okay? And it says that it's 4 times that number, so 4 times x. And then it's 3 fewer than that, so subtract 3. Oftentimes when we're talking about 3 fewer or 3 more, which is like an addition or subtraction, I put that at the end, okay? And then if you have 4 times a number, or 3 times a number, some type of product, that's what I put first. So let's say I have this little problem over here in red that I just wrote. It says 6 more than 3 times a number x. Well, that's 6 more, that's like adding 6, and it says 3 times a number x, so I'd have 3x, because 3 times the number x, and 6 more than that would be plus 6. It'll take a little bit of practice. There's plenty of that stuff online in your book. Sometimes we're asked to evaluate. Again, we're just doing a bunch of different stuff with expressions. So when it says to evaluate, well, I'm given some values of a and b. And as you see, we have an a and a b in our expression. Now you could have multiple a's or multiple b's or whatever variable we're using, but essentially we're just doing this. We're plugging our value in to each variable. So let's do that. I've got 8 times, and then we have a. So I usually put my number in its own parentheses, minus 5. And again, I'm just using these extra colors because I think it helps to see all that. You don't have to do that, but you can if you want when you're getting started. And then we've got b, which is 3, minus 6. And we're just going to go ahead and use our order of operations. Well, I've got to do what's in the parentheses first. So over here I've got to do this part. Negative 3 minus 5 is negative 8. So I've got 8 times negative 8 plus 4 times 3 minus 6. And then we're going to multiply these, which is negative 64. Multiply the next ones, which would give us 12, and then minus 6. And then we could put this all together. Well, over here, if you're just doing this in your head like Jason Derulo, you're going to have 12 minus 6 is 6. And then add that negative 64, so we get negative 58. And there you have it. And you can go right in order, again, with addition and subtraction. Sometimes it helps to simplify some of the easier ones first. But you could have done negative 64 plus 12 is negative 52, minus 6 gives you negative 58. Or you can combine these guys here, which is 6, and you have negative 64 plus 6 gives you negative 58. So there's a couple ways of going about that. Oh, man. Now we got a little bit of fraction action, my favorite, and some exponents. Woo! Alrighty, so same idea. We've got 3 times, and then we have 4 squared minus negative 3 squared, close your parens, divided by 2. So let's simplify this. Well, first, parentheses, innermost parentheses. So our innermost would be like this guy here and this guy here. And then we go to the exponents. Since there's no operation in these parentheses or in these parentheses, now we go to our exponents. 4 squared is 16. So I'm going to have 3 times 16 minus, and then negative 3 squared. So we're talking negative 3 squared is 9. All over 2. So 16 minus 9 is 7. So this right here is 7. So 3 times 7 is 21 over 2. And there's my final answer. Pretty rad, don't you think? So this next question here says, will the value of the expression change if the parentheses are removed? Meaning this parenthesis here and this parenthesis here. Well, let's see. If we were to remove this parenthesis and this parenthesis, I would essentially have this. 3 times 16 minus 9. What I just did here is I evaluated my exponents here, the squared part, And then we would have, because the exponents would still go first, all over 2. But now what I would do is rather than combine these two to get 7, I would do 3 times 16, which is 48, minus 9, which is 39, over 2. And yeah, it would change. Absolutely would change. So that those parentheses around the x squared and the y squared really make a difference in this problem. So you've got to pay attention to those parens. Alright, let's take a look at this one. It says ticket prices for the football games are $5 for adults, $2 for students, and $3 for senior citizens. What's the algebraic expression for the price of the entrance? And then we've got a follow-up question. Suppose 200 adults, 500 students, and 30 senior citizens enter the game. How much money was collected at the gate? So our expression, we're going to be using that to figure out our total amount of money. Well, if it's $5 for adults, so $5 for each adult, well, $5 times the amount of adults, plus $2 for all students. And be careful when using s as a variable. It can be kind of tricky because it can look like a 5. And then plus 3, and then we have senior citizens. We'll put that as a C, I guess. Alright? And let's actually make the students, let's make that one let's just use A, B, and C. Okay? So we have our A for adults, B for students, and C for senior citizens. Cool? Alright, well, if I've got 200 adults, well, we just basically plug and chug. 5 times 200 adults, plus 2 times 500 students. Because A, B, and C represent the number of adults, the number of students, and the number of senior citizens, respectively. And that word respectively is important. You'll see that on standardized tests when they give information about, like, say, 3 variables at a time. If A, B, and C equal 6, 7, and 8, they're talking about A equaling 6, B equals 7, C equals 8. And I just use that here to say that we have 200, 530 adults, students, and seniors. Okay? So now we can just go ahead and plug this into our calculator. But I bet you some of you could probably do this in your head, like Jason Derulo. This first one here, 5 times 200 is 1,000, 2 times 500 is 1,000, 3 times 30 is 90. So what's that? 2,090. Bada boom, bada bing. So that's how much money, dollar bills, that were collected at the gate. Alright, the next thing we're going to do is simplify an algebraic expression. And this will actually be the last thing for this video. So to simplify, basically we're combining our like terms. You did this in Algebra 1. We have negative 3x squared plus y. The first thing I need to do, distribute. So plus 2x minus 8y. Next thing, I got to combine my like terms, and I also like to write it in standard form, highest degree to lowest degree. Well, my highest degree would be the x squared. The squared is my degree, degree of 2. So we'll put that first. Then I've got plus 2x, and then those y's here and here will go together to become negative 7y. Now really the x and the y could have been interchanged here. They could have gone in any order, really, because they're both a degree of 1. There's really a 1 up there that you don't see, that we don't write. But I'll just, either way would have been okay. But I kept the x's together. That seemed to be the nicest looking to me. Cool? So distribution, you really just got to follow your order of operations when you're simplifying an algebraic expression. Man, that was fun.